Welcome back. Um, this is one of the last videos for chapter 21 on more tests and intervals. So in the last video we ended off here, and again to show you the inverse of our diagram here of alpha and beta. So this diagram shows the relationship between these two concepts. Suppose the null hypothesis is true. So again, here's our true. Here's alpha. And then down here, suppose the null hypothesis is not true. Here's beta. As alpha decreases, beta increases. The previous figure seems to show that if we reduce type 1 error, we must automatically increase type 2 error. But we can reduce both types of error by making both curves narrower. How do we make the curves narrower? We increase the sample size. So again, if we make them narrow, notice our normal model is kind of squished together here. This figure has means that are just as far apart as the previous figure, but the sample sizes are larger. The standard deviations are smaller, and the error rates are reduced. So again, alpha and beta. Alpha is when we are supposing that the null hypothesis is true, and beta is when we suppose that the null hypothesis is not true. So again, take a look side by side. Our original comparisons, notice the normal model, and then compare of errors with a larger sample size. Notice, again, here's, well, it looks like maybe 1.5 standard deviations away from our mean. Here's 1.5 standard deviations from our mean. Notice the area between the two. This one over here has smaller area, therefore smaller error. So there's lots of things that can go wrong, and we'll list them here. Don't interpret the p-value as the probability that our null hypothesis is true. Again, just like in chapter 20, don't do it. The p-value is about the data, not the hypothesis. It's the probability of observing data. So again, it's the probability of observing data, this unusual, given that our null hypothesis is true, not the other way around. Don't believe too strongly in arbitrary alpha levels. It's better to report your p-value and a confidence interval so that the reader can make his or her own decision. Don't confuse practical and statistical significance. Just because a test is statistically significant doesn't mean that it is significant in practice. And likewise, sample size can impact your decision about a null hypothesis, making you miss an important difference or find an insignificant difference. Don't forget that in spite of all your care, you might make a wrong decision. Thus, you have two types of errors. There's a lot more to hypothesis testing than a simple yes-no decision. Small p-values indicate evidence against the null hypothesis, not that it is true. Alpha levels establishes level of proof. It determines the critical value z that leads us to reject the null hypothesis. An hypothesis test gives answer to decisions about your parameter. Confidence interval tells us plausible values of that parameter. And we've learned about the two kinds of errors we might make and see why In the end, we're never sure we've made the right decision. Type 1 error is where you reject a true null hypothesis. Probability is A. And type 2 errors where you fail to reject a false null hypothesis, and that probability is beta. So type 1 errors is when you reject a true null hypothesis. Again, the probability is alpha. And type 2 error fails to reject the false null hypothesis, and that probability is beta. Power is the probability we reject a null hypothesis when it is false. And again, power is 1 minus beta. Larger sample size increases power and reduces the chances of both kinds of errors. And that concludes our videos on Chapter 21.